Okay, now in terms of solving for number 1 and finding out the shaded area while integrating with respect to y, okay, again going back to our quadratic and linear functions, okay, we have with the quadratic, we have that y is equal to x squared. Linear, we have y is equal to 12 minus x. And to be able to integrate with respect to y, we're going to make the transition from expressing these functions from y is equal to over to x equals. So for y is equal to x squared, rewriting in terms of x equals, take the commutative equivalent of our function saying that x squared is equal to y, and with the square root method, okay, we have x equal to plus or minus the square root of y. And as for y is equal to 12 minus x, rewriting, we had that x is equal to 12 minus y. And so for the graph, okay, which I have illustrated, not exactly drawn to scale, but for what we have here, okay, we're now integrating with respect to y, so you're looking at, as opposed to vertical slicing, as was the case used as a visual for integrating with respect to x, we have horizontal slicing, okay, where we have as our visual tool for integrating with respect to y. So think of right minus left. Okay, now we have two regions upon which the graph is going to be subdivided, and if you notice, okay, we have key points here. We have the vertex at the origin, our intersection point at 3, 9, and the other intersection point at negative 4, 16. And looking at what we have, let's say moving from left to right, okay, we have at the top, we have negative 4, 16, and as you proceed, okay, notice we have x is equal to 12 minus y, our linear function, and for this activity it is going to be perpetually to the right of the left hand side of the parabola, which in this case will be, since it is to the left of the y-axis, this will be where x is equal to negative square root of y. So you have 12 minus y is to the right of negative square root of y, as we go down from y is equal to 16 to y is equal to 9. And as you notice, as you get lower, the linear function is outside the boundary, okay, upon which the shaded region is occupied. So in the lower realm, I'm labeling this as R2. Okay, we have only activity is going on between the right and the left halves of the parabola. Right half being positive square root of y, left half being the negative of the square root of y. And the combined shaded area is going to be adding together the subtotals arrived to from taking the area of R1 and the area of R2. So we have that the area is equal to that of R1 plus that of R2. And for first region, okay, again we are proceeding from y is equal to 9 to y is equal to 16. Right function is 12 minus y. Left function is negative square root of y. And so we have substituting accordingly, setting it up in integration terms. This is what we have for the area of the first region, and then for the second region, or the lower region, you have positive square root of y, subtracting the negative of the square root of y, and so we had the integral set up from y is equal to 0 to y is equal to 9, and then again the difference between square root of y and its negative. And as we look at following through, okay, combining, we have 12 minus y. There's no combination of like terms, but we do have subtracting negative square root of y. We have plus y to the 1/2, and the square root of y minus the negative of the square root of y. That's going to go to 2 times the square root of y, or 2 times y to the 1/2, as y goes from 0 to 9. And as we look at taking the power rule of integration, okay, we have with the statements, okay, so we have 12y minus y squared over 2, y to the 1/2, okay, the antiderivative is going to become 2/3 of y to the 3/2. And then we have for 2 times y to the 1/2, again, y to the 1/2 has an antiderivative of 2/3 y to the 3/2. Double that, we get 4/3 of y to the 3/2, okay, letting y go from 0 to 9. And if you were to substitute accordingly, it's going to follow that for the numbers that we have involved. Okay, if you were to substitute in the upper and lower limit values respectively, it's going to follow that for what we have present. Okay, for the area of R1. Okay, this will end up at 127/6, and 9 to the 3 halves will be at 27 times 4 is 108, divided by 3 is going to be at 36, and 36 is 216/6, and if you add to 127/6, we still come out to the area at 343/6.